Perhaps we can get started here, and welcome back. We put a poll question up here just to get you to maybe share some things with us that perhaps didn't come out elsewhere already regarding the installation of Anaconda and access to the cloud environment, if anyone was actually trying to use that. Now, I guess there was one issue that seems to be significant here about the Conda part. I guess, was that for a person using Windows? Yeah? Yeah, okay. So, I don't know, Henrik maybe knows.
Yeah. So the ones having problems with the Conda version and this kind of installation things. So the thing, what is the problem with Windows is that basically when you are installing the Anaconda software, it actually asks if you want to put Conda as the system variable in Windows. And if you haven't clicked on that, so basically then when you use command prompt, for example, Windows cannot find this Conda program. There is a quite easy way to do it. The question was asked in Slack, and basically I answered there, so you should be finding the information in Slack from lesson 1 channel. I can also pin that question so that you can easily find it from Slack. And basically, there were quite many questions about the course stuff now posted for me, for example, via email. Please don't do that. So what we would like to do is that you post all your questions in Slack so that everyone can actually see them. So that we won't have these like we have 15 students asking the same question. Instead, you can go and check like a few times before from Slack, like is there a question about this before actually putting your own question and then ask, and then we answer there, and then everyone can actually see the answers and reasons why something behaves as it behaves. So that's what we would like to do. So if you have problems with Conda, so yeah, Slack is the place where to find information how to solve this information. Yeah, but it's otherwise.
So there's one question here about what is Anaconda, and that makes me wonder, is there someone who wasn't here last week who might not know what Anaconda is? I mean, it's a type of snake if you're wondering about that, but yeah, if you weren't here last week, it would be good when we take a break for you to come up and just say hi so that we know and we can kind of fill you in on a few things. We're assuming at this point that you've made a GitHub account, that you've made a Slack account, and that you've been either able to install Anaconda to use Python on your own machine, or you're trying to use the cloud environment where Anaconda is already installed. So, if any part of that sounds very unfamiliar to you, perhaps it's good to come chat with us.
Yeah.
And take a break.
At the moment, there were some 15 people who still didn't have GitHub account, so that is something that you should basically do right away if you haven't done it. It's fairly straightforward, but basically from now on we will actively use that, so that is definitely needed. And the not Spider, but the Slack account as well. So there's going to be a lot of information available from there, and it's the place for you to communicate. So it's also important to have a Slack account. But there are instructions in the first lesson and exercise how to do this, so it should be quite straightforward.
There were at least 2 people, I think, in the intro to quantitative geology course who had signed up for a Slack account and never made a post about whether they had made a GitHub account or not. So that was part of the assignment for this week. If you haven't done it already, please do that soon. I don't think we're going to be grading particularly harshly if you haven't done that. We just want to have all this information so that we know who is who and which accounts go with which people and things like that. Otherwise, did anyone have a problem in like getting a GitHub account or figuring out how to sign up for Slack? I know there was an issue initially with the Slack link expired or something like that, so we made a
Yeah.
new one. But were there any problems with Slack or making a GitHub account?
Okay, good. Yeah. Okay, maybe we can continue with the actual content this week.
Alright. Okay, now I think everyone should see this. Okay, so we have the lesson 2 materials on the website. Now, and basically, what is the kind of what are the topics of this week? So again, we continue and start by going through a little bit of the course environment stuff. So basically, we will introduce you to version control and how to use GitHub during this course. So those are of course really important things because that is how we do things during the course. So we want you to have a little bit of background information, what is actually going behind there. And then the Python part of this lesson is about data types, lists and indices, and a little bit about the concept of objects. And then from that onward, we will, or they will talk you about how to write scripts using Spider, and then we will go through the exercise 2 and tell you what you should do on that one. And then we have also a dedicated page on the website showing hints to the exercise 2, and we will continue to do that. So basically, if we see that all of you are stuck with specific parts of the exercise, so these hints pages that will basically be part of the course site all the time, so you will find some information and if we will update some information there if needed. So that's those pages are good places to visit if you face some problems with the exercises. So the learning goals for this week, so you should be able to understand the basic concepts of what actually is a version control and why it is useful. Then you should be able to access your space in github.com. Of course, we hope that you have already went through and checked the site a little bit, but also how to kind of interact with the site, so how to download materials, how to upload materials there, and so on. And then from the Python part, you should be able to explain the concept of an index value and know what index value actually is. And then you should be able to use some basic things with Spider IDE, how to create, edit, and test scripts, and that we will do throughout this course. In addition to these, we added few kind of background information and additional information here to the website. We added this kind of page showing some basic terms related to Python and version control as well. So we will add kind of typical terms that are used during with Python programming to this website. So if you're wondering what is an index or what is a function or whatever, so you can actually find some basic information about them from this page here. Then we also added a separate resources page. So basically we will add here some good books and websites and tutorials and so on to this site. It's now not complete, but we will kind of continuously add things on this page, so that you know that these kind of things are now also available from the site. Okay, but let's continue with the actual topic. So version control. this is this kind of nice example of the problem that we might face doing some kind of master's thesis or some kind of document using Microsoft Word. So basically, at one point when you have finished your master's thesis, you might be really happy and so on, and then what you basically do that at that point is that you give it to your supervisor, who then adds his or her comments to the document, and then you have the next version, and then you kind of do the modifications of the file and have a new version and send it to supervisor and so on. And finally, basically what is really often happening is that you have these really awful files with all sorts of difficult names to understand what is actually happening there. So this is what often happens, and it's because you kind of want to keep the history of the file so that you have the original one that you actually first submitted to your supervisor, but then you of course want to continue working on the same file. How many of you are actually have done something like this? Yeah, okay, quite a few. Yeah, this is something that I have also done in the past quite a few times. So this is something that comes up in the work when doing science. So basically, what we can avoid with version control is these kind of situations. So it kind of helps you to have a good history in a clean manner of your files. So basically, what is version control? So version control is used to track and store changes in your files without losing the history of past changes. So it's in a manner a bit similar to if we think about Word. So you have the track changes, so you can actually see the change that has been done to the document, but with the track changes it's really difficult to actually see previous changes except the or longer history of the file except the previous change that has been made. So it can be quite complicated to find changes that were done 2 weeks ago. So it's kind of messier in Word. So version control does this quite nicely. So basically how you can think of version control is that basically it's certain of you can think it as a tape. If you remember those things that you can actually rewind and put the play button. I guess most of you are the CD generation, but at least I still remember the C tapes. So basically it's kind of system that when you listen to the music and basically when you rewind to the end, so you can actually play back each change of that tape. So this kind of illustrates the thing. So how you actually use version control is that you have certain document that you start with. So this would be the version 1 of my document, and you kind of commit those changes. So whenever you commit the change, the version control starts tracking the changes of that file at that point of time. And whenever you then basically make a new addition to the file and commit it at that point, the history of the file is being tracked. So basically you will end up having the same file with the 3 initial lines and then the additional one in this place. And you can go back in history to actually see the first version of the file, but you still continue working on the at that time the stage of the file, and then you can continue, add more stuff, delete some stuff, do whatever, and basically version control all the time keep track of the changes of that file. So that is the basic idea behind version control, so that you don't actually you keep the track of those changes. Yeah. Yeah, and basically, of course, with version control, you can also decide, especially when you're working with multiple different files. So most commonly when doing programming, you have actually not only one file that you are working on, but you have multiple ones. And basically a repository is basically a folder where you have all the files that are tracked by this version control, and then whenever you are doing a commit, you can actually choose which one of the files you want to commit, and that those ones will actually make the commit, and the history of those files only will be tracked by version control. There are multiple different version control systems. So there are these old ones, but one of the most common and popular ones nowadays is this Git that was developed by Linus Torvalds in 2005. He's an interesting guy, a Finn from our university actually, and basically why he did develop this Git was the fact that he was really disappointed of everything that was available for doing version control, and then he was like, okay, I can do a better work in 2 weeks, and that was what he basically did. So he developed this Git version control system to track the changes that he's doing to make the Linux kernel what he developed, and is the kind of father of that Linux kernel that is used a lot nowadays. It runs in the background of all the Android phones, for example. So Git is this kind of version control, and GitHub is then again, it's kind of, the name already says it, that Git is basically kind of background, the tool that is used to run the GitHub site, and the hub kind of tells that it's this kind of common place in the web where you can actually share stuff and collaborate and put these repositories to that site so that they are available for everyone. So basically that is exactly what we are going to do throughout this course now. Yeah, so why to use it? Of course, I already showed you an example, so it's good that you are actually working on a single file, not to have different files for different versions of the file that you're working on, so you kind of avoid the situation of having different names for different versions, and it gets really soon really ugly of doing the version control that way. But then I also mentioned, so it's really good that you have the ability to go back in time with the versions the version of the files that you have, because you might end up, when you are doing programming and you are kind of committing changes, and at some point you might be in a situation where something doesn't work anymore, and then it might be a situation where you actually cannot find the reason why is it actually so that this doesn't work. So in these kind of situations, it's really handy that you can actually go back in time and find the version of the file where everything was still working, and then you can compare the current version of the file to the one where everything was still working, and try to find where something is wrong at the moment. And if you still cannot find out what is wrong, you can of course basically take the version from the past and start working from that on again. So that is really handy as well. And also version control allows, one of the biggest benefits is that basically multiple people can work on that same file. So it's really easy to collaborate with many people using version control such as Git. Then we have some basic vocabulary, so some basic terms of version control. So these repository, commit, revision, clone, pull, push, merge, these are such kind of terms that come out and you will face quite often when we start using the version control. So as said, repository is basically a location where all the files for a particular project are stored. And basically each project, so in your case, each exercise is that you are working on is a project of your own. And basically you will have access to that repository that you're working on, and then additionally we, the teachers and the assistants, will have access to that repository. But anyone else cannot access it, so it's kind of only your workspace, and we can also see that and see if you need some help, so we can actually go and check like what is going on here, and then we can give you some tips and advise you how to proceed. So the commit, so it's basically the step where when you want to kind of tell the version control that okay, now I have written some parts of code that are now functional, so now I want to take a snapshot of this project that I have. And then you basically make a commit, and then basically that moment of time will be tracked by the version control, and you can you can go back in history to actually see that point of time. So basically it's good to kind of regularly do commits and not to have like hundreds of lines of code before you do a commit, because then basically you won't see the initial changes that have been done in the code that you are doing. A revision and version, so well, the names kind of say it all. So it's the version of when some changes have been done. Then cloning is something that comes up quite often. So basically cloning means that basically you take some project, for example from GitHub, and basically copy all the stuff from the repository to your own computer. So that is kind of cloning. So it's basically downloading stuff from the web or wherever you have the project running. Pulling and pushing. So basically if you have a project running already on your own computer, and then for example when doing the course site, Dave have done some changes to the project. So basically before I'm able to see the changes that Dave had made to the project that we are working on, I need to pull those. So basically then I take only the changes that Dave have made, and they are merged to the project and the version that I have on my own computer. So that is basically pulling. So I take the changes from certain collaborator and merge them to my own version of the file. And pushing is basically the thing when I have done some changes and I want Dave to see them, so I push my changes to the repository in GitHub, for example, and then he is able to actually see those changes. And the merge, well, it's basically when the two set of changes are kind of brought together and applied. Yeah. And GitHub.
Can I add
yeah.
one thing just quickly? Most probably for, I would guess, all of you, you won't do any pulling, pushing, or merging yourself. So it's something that's built into Git, but if you use GitHub, where everything is kind of online, you don't necessarily need to actually do these things. The way it works with Git normally is you don't necessarily have to be connected to some online place to keep versions of the software that you're working on, or the text that you're working on, or whatever. It's all kept locally on your machine, and you can save all the version history and everything without ever going online. But when you use GitHub, the convenient part is that everything is available on a website, and so you can almost think of it as a place to like back up what you're doing.
Yeah.
But as far as like pulling, pushing, and merging, if they seem kind of confusing, don't worry too much, because you won't necessarily directly do those things.
Yeah, yeah, exactly. Yeah. We have some materials added to the website and some good links. So basically, if you want to start using these, there are materials that will show you how to do it. But really, we don't. It's kind of a world of its own, so we don't have time to go into that one. So we are doing this in a more easy way than what is usually actually done with programmers and how we actually do it. But at least you have the basic idea how these things work. And I said one really thing is that Dave mentioned the backup thing. So how basically I nowadays work quite often is that I do whatever computer it is that I'm working on. I do some coding there, do some analysis and so on. And then what I do is that I basically push those changes to GitHub, and then I can take whatever computer I have available and where I don't have those codes available. But what I do is that actually I go and pull the changes from the GitHub and start working on that computer. So it kind of makes life really easy if you have multiple computers that you are working on. So you can just push the changes to the cloud, and then whenever you want, you can take another computer and start working on the same project. So it kind of makes this really easy. Yeah, so then GitHub. So basically what I will now show you is I will tell you a little bit what are the kind of functionalities of GitHub, and then I will show you the basic kind of workflow, how we are doing things during this course. So as said, GitHub basically relies on Git, so this Git version control is all the time on the background of Git, and it keeps track of the changes. Then as mentioned already, so GitHub really is a social collaborative network, so it has quite nice functionalities, not only to kind of work on the same project, but you can actually also communicate, point out issues that you might have, put even some timelines when certain things should be done and so on. So there are a lot of functionalities in this kind of from the social perspective as well. GitHub is the most common and most popular place where to share open source and data and codes and scripts and documentation about anything, and it is really often used when doing science. So it is a place where you will most likely end up going quite often when you start doing data science and data analysis using programming. So GitHub sites will be quite familiar for you when doing those. Yeah, and then what should always be done when doing any programming is that you should document your work, so that basically when you have done something and you haven't touched that project for 2 years, but then you have a moment that you actually, okay, I need to start working on this project again. So unless you haven't documented what you have done properly, it takes a lot of time for you to catch up what was done in this project, even though you have written it yourself. But 2 years can make quite you can forget a lot of stuff even though you have done it yourself. So GitHub is a nice place where you can also do documentation and do websites such as these and so on. So that's something that is also quite often done in GitHub. And basically each repository in GitHub includes a file called readme.md, which is basically this file format called Markdown that is used to, you can do with Markdown quite nicely formatted documents that have these kind of headings, and you can add links and whatever. So that is something that we will also learn during this course. So basically you should be able to document your work on the web quite nicely and do even some nice formatting using this markdown. So basically you can be able to do some kind of web pages after we are finished with the course. Yeah, then there are some online tools available. So basically you can do all sorts of stuff also in the browser, so only using the GitHub website. So you don't necessarily need to actually use your own computer at all. Whenever doing the actual programming work, that is basically the thing that you need to do, but like adding documentation and so on, so you can basically do it directly on the GitHub website. So you can add commits and add changes to different files. Yeah, and then as mentioned, the issue tracking is really useful as well. So if anyone notices some errors in your code that you have shared on GitHub, they might raise an issue that, by the way, have you noticed that you have this bug on this code? Or that, by the way, have you noticed that this could be done in a little bit different way, which would be much more effective? So it's kind of way how other people can comment on your stuff that you have done, and you might get hints how to improve things. So it's really good thing to have this kind of issue tracking functionality. There are some resources additional to what we will show, like showing how to use GitHub and different functionalities of it. So you can take a look of these if you're interested. But then let's move forward. So now I will basically show you the workflow, how we will do things. So how we will distribute you the exercises, I was seeing already in the morning that someone of you was actually cloning and using the classroom link, so that the repository in the exercise 2 was actually pulled and done. So we will use this classroom for GitHub to distribute you the exercises. So basically when we click on this exercise 2 button, we will end up having this kind of site. So this is basically taking you to a GitHub. So we are actually now on this classroom.github.com. If you are doing this for the first time, there might be a site asking you to authenticate or authorize the GitHub Classroom plugin. So you might be needed to actually accept that first. But after that, you should be ending up to this site. And this basically say that, okay, accepting this assignment will give you access to the exercise 2 day WIP. So basically what this will do now is to create a repository called exercise 2 day WIP, which is a copy of the exercise that we have created for the course. And basically when I press the button, I came into this kind of site, and now we are ready to go. There's a link to the repository that we can access, such as this, and when we click on the link, we end up to GitHub site, and what we have here is the exercise 2 repository that you will do today. So this is kind of the exercise for this week. There are different things that you need to do. So we have basically 3 different problems that you want to solve, and this is the thing that GitHub Classroom does, is that it kind of makes repositories for each one of you separately, so that you will work on your own project, not working together. So that's what the Classroom does. So nothing more complicated than that, but that's how we do things. Then what we can do in this repository, well, first of all, we can see that in this repository called exercise 2 day WIP, we have different files here. So we have a folder with images, we have some license, then we have this readme.md file. That is actually the thing that we are seeing on this site right now. So the contents that are kind of screamed to the site comes from this readme.md file. And then we have this station ages.py file. So this is a Python file that we will start working on this week. Okay, maybe I go back with the Geo-Python here. So that's GitHub Classroom. So now I will show you how to work on the assignment. So basically how to download the data, how to save your work and changes to GitHub, and how to write answers. So it's really kind of, this is now the most simplest way of doing version control and actually pulling and cloning stuff from this repository. So we are actually using this web interface of GitHub instead of using the kind of command prompt based or terminal based Git commands that are usually done. So basically, for example, when I want to work on that station ages.py file, so how I can download it is that basically I press the right button, which is, how do I do that?
You tap two fingers together.
Two fingers together. Okay, cool. Now I know something more about Mac. So basically how you will download the stuff is that you right click with the file name and then just press save link as. Let's see how this works in Mac and this browser, but usually it, yeah, so basically now it asks you where you want to actually save this file. Well, I put it on downloads. And then just save, and then basically we are downloading that file, and now we can maybe show in Finder, and now basically here we have the file, and now we can actually start working on that file on your own computer. You could do the changes also in the browser, but you don't really want to do that because you are not able to run the code that you have done. So what you really want to do is to take the code from GitHub, download it, then launch your Spider IDE and start working on this one. Do we have the Spider available? It's not open, so go.
But I can't open it if you want.
Yeah.
It's easiest to do from terminal.
Yeah, there it is. So now I will launch the Spider that hopefully every one of you have already seen before. Okay. No. Let's close that one. So this is the place where we can start working on the code. So basically we have the file and open, and in a similar manner as any program, Microsoft Word or whatever, you want to open that file, and now we just go to the place where we downloaded it, and it's somewhere here, so station ages.py, and okay, not the way how I wanted it. Okay, so this is how it seemed to work on Mac.
Here, let's get back to the
Yeah. Yeah. So there are some browsers where it works like this and some browsers where it doesn't. So this seems to be a computer where it doesn't work like that. So how we can actually download, so what it did now was that it actually downloaded the HTML page of that file. So that is not what we want. So how we need to do it is that basically we first click on this station ages.py file, and then here we actually see the code that we have, and then we with the right button, not that one. Oh, okay. Now it did something. Cool. Yeah. So with right click with the raw button here, basically giving you the raw materials or raw code, and save link as, and then the same thing. So what I want to do now is that, and that is also a bit stupid, that it automatically tries to save it as a text file, which is a bit shame. So we actually want to change it as stationages.py, so it's a Python file that we are working on, and then I want to save it. I want to yeah, the raw button.
What if it opens in the HTML page?
So if you press this one, so basically if you press it with left button, you will end up into this kind of web page, but you don't want to do that. So what you want to do is that you put your mouse on top of this raw, and with right click, so then you have this save link as or something similar.
I have only save link.
Yeah, well, it's the same thing. It might vary a little bit. So that's how you will be able to download it. And now let's see if there is the, yeah, okay. Cool. So let's see if we now have the right version of the file. Hopefully we do. Yes. So now it looks like what it should look. So basically this is now the Python file that you can open on Spider, and on the left side here we have this kind of editor view where you can start modifying stuff on this file, and what you see here is that you have some information in the file. So I won't start doing any actually edits on the file, but I will just create one minor change. So I will print hello here, print hello, and that's it. And then I will save the changes, file and save. And then what I will do now is that I will upload this file back to GitHub, and we can see that it basically will update the file in the repository, and we will commit the changes that we will do. So
if any of you are following along and doing this at the same time, which is a good idea, if you're having problems, just raise your hand or something, and one of us will come and try to help out if you get stuck or something like that.
Yeah.
Don't worry about interrupting. Just
yeah,
put your hand up and we'll come help you.
Indeed. Okay. Now we are here, github.com. Okay. So this is basically the view that we will see. So we will see every repository that have been created by you under this Geo-Python 2017. So basically your repositories will be saved under this organization that we will have. So, but you won't be able to see the repositories of your friends. So only us will be able to see these. But what I want to do is that I want to find this exercise 2 day WIP, so the repository that we just created, and now I want to open that one, and basically what I want to do now is that I want to upload the changes and commit the changes that I did just before to the file. So how you can commit the changes to the stationages.py to GitHub is that there is this upload files button here. You can see it. Maybe we put this a little bit larger. So there is this button, and when you basically press that one, you come into this kind of page where you can just drag and drop all the files that you want to commit and add to the repository. So what we want to do now is that we want to drag and drop the file that we just modified on Spider and see what comes out. Okay, so now I need to go to the downloads. So basically I just edited this stationages.py file, and what I want to do now is that I just take this and let's see, how do I drag? Well, not like this. This is a bit annoying. Or choose your files. So what I can do also is that I use this. The tracking is easier if you know how to use a computer, but as I don't know, so I will do it like this. So what I will do is that I just upload it like that, and now we see that okay, we are at the moment committing changes to this stationages.py file, and it is now added to this commit. And basically, whenever doing and committing changes, so what version control and what Git wants you to do is that you actually comment what you were doing when you so kind of give a short message what have been done. So basically what I did now is that I made a minor hello change. So basically I did just some minor stuff, but usually what you have done is that you have built some like functionality to your code. So you kind of want to say that I created this kind of math function that calculates or converts temperatures from one temperature from Fahrenheit to Celsius, for example. So that kind of message you want to add when you commit the changes. So now what the last thing that is needed to do is that we want to press this commit changes, and now it will be processed. It shouldn't take too long. And now what we will see is that here we have the kind of change message. So it will be shown to you always when you commit changes, and you are able to see that okay, this has been just now updated this file, and when we go and check the contents of it, we can see that okay, this print hello came here. So this is basically how we do things during this course, is that you do the changes, you regularly upload your files to GitHub. And basically what is really important is that you really continue working on the same file. So you don't rename it, you don't create stationages _1_2. Instead you work on the same file so that the history of that specific file is tracked all the time. So that's the whole point of having version control. So we are not having multiple different files. And why this is really handy, as said, we can go back in history. So when I click on this stationages.py file, is that we have this history button here. So basically when I press this one, we can see that what kind of changes have been done to this file. Okay, we can see that okay, Dave, actually last year this file was named cat treats, and now we modified this a little bit so that we are not working on cats anymore, we are working on some weather data. Then Dave basically updated some stuff to the file, and now what I did as Dave was that I committed this minor change to the file. And then we have these buttons here available, and basically what these are is that, for example, this will kind of get the what was it does, so browse the repository at this point in the history. So basically this is the current version that we have, but if we would like to, for example, see the version from last year, we could press this one, and well, we can go and see how it looked last year. So this, oh yeah, sorry. Yeah, good. If you cannot see it, just yell, so I will try to do. So this is basically the version of this file last year that we were working on. So we were doing some similar stuff, but with a little bit different content. And then basically, if we want to see the version, last version, so this is now the version before my minor change of that file. So we are able to see the whole all the contents of the repository at that point of time. So it doesn't matter if you have made changes to 10 files. So basically you are able to see the changes of all of those files that were tracked at that point of time. So it can be a really powerful tool. What is also really handy is the fact that you can actually, by pressing the button in the middle, you can see what has been changed. So basically here we can see that we have this green line. So there was 2 additional lines added into this file, and one print hello command was added. So it's really handy that you can actually see what was changed in the file. So now we only have two changes in the file. So basically 2 additional lines were added. But of course, when you have a lot of stuff happening, so it's really handy that you can see with this green color are the additional lines, and with if you delete something from the file, they are colored as red. And Dave has something.
Yeah, just one minor thing to say. Like, we basically tell you in the exercise that you should save every time you make a change to your file. That you know, if you changed it and tested it that it works, then you should make a commit and save the updated copy. And that's kind of a good way to do things in general. So maybe you don't want to have a change that's only 2 lines, but you also don't want to like do the entire exercise, make all of the changes, and then make one commit, because it then gets difficult to go back and find little pieces of what was changed. So
yeah,
I don't know if you mentioned that, because I was kind of not paying
no,
attention.
no,
But,
good comment. Didn't mention, yeah. Yeah, so these kind of things you can do straight from the browser. So you can go back in history, upload files, download files, and so on. So that's basically how we will continue doing work throughout the course. So most often you have some kind of file that you start working on as this kind of starter script, or then you need to create a file of your own and upload it. So it depends a little bit what we are doing, how we will continue. And then basically, yeah, maybe this is something that Dave will show you later on in the course, but let's see if we still had something that we want to show you regarding this. Maybe not. Yeah, modifying the starter code, committing your work. So everything is documented on the website. So if you have trouble understanding what I'm trying to tell here, it's maybe easier to read it yourself. Yeah, okay, answering them. Yeah, maybe we go still, I will show you a little bit about how to actually use Markdown and how to answer the questions using the Markdown. So what we want you to do basically this week is that we want you to edit this file. So we want you to edit this exercise 2 blah blah blah. So this readme file. So when I click on this one, so when I click the file, so this is basically all the content that we will see from the file. So it is actually the file that comes when you enter the repository. So that is something built into this GitHub website. So it tries to find these readme.md files, and it will show automatically the contents from that file at the front page of the repository. How we can edit this file? So this looks really nice. As you can see, we have these links and bold titles and whatever, some these kind of bullet points and tables even. So this looks nice, but of course we have actually, so how it looks when we are actually doing and producing this file, so it looks something like this. So there is this kind of a specific way of writing markdown text and markdown documents. It's really fast to learn. Last year people were really, they got it quite quickly. So it takes some time to kind of understand few pieces, but basically the components and elements that you are working on are fairly simple. So for example, if we want to put a heading for the file, we just put this hashtag in front. And when you want to have a kind of secondary order, like heading 2, so then you just add one more hashtag before the title that you want to see, and so on. Then the text you can write as you would write any text into the file, and then you can also do, if you want to put some text on bold, you can do that by putting these stars in front and after the pieces of text that you want to put on bold. So fairly easy to do. Also putting links is quite easy. So you basically put the text that you want to be shown on the website. So basically the link that you press, so you will put it inside these square brackets, and then you have the actual link inside here. So it's also fairly easy to do, and of course it requires some repetition from you so that you start remembering how these things were done. But basically when you have done this for a while, it kind of you do it automatically, and there is no kind of really hard brain work that you need to do to remember these things. So basically it becomes fairly fast to do, and for example, at least for me, and I guess for Dave as well, so we work on these files in a similar manner as using Word and using the comments from there, so it becomes quite easy to use. Then what about else in here? Maybe the bullet points is something that I would like to show you. So the bullet points, well, nothing too difficult here. You just put one dash and then the text, and you have a bullet point on the side. So this is basically something that you will end up modifying. So you need to add your answers to this file. So whenever we have some questions for you and we want that you will answer to them. So basically we have a separate section at the bottom of the file where we want you to answer to these questions. So basically you add your answer here, and then you commit the changes, and it will and they will be shown on the readme.md. Maybe I do a single change, so I will do like this. This is my change. And basically what you need to do, again, as we are under the version control, you need to commit that change so that it will be tracked by the version control. added answer to problem 1. So this would be basically quite nice commit, so that when you have done the problem 1, you can commit the okay, so now I have been modifying the file and I have answered to the problem 1, so this would be a good place to commit the change. And then we do, and when we are done with this, at the bottom we should be having the text that I just added to this file. So fairly straightforward to do, and when you learn to do this, you are already quite in a quite good place, so you can basically start working and documenting your stuff on GitHub, and that is basically what all programmers do. So it's a good skill to know how to write Markdown and how to be able to upload it into GitHub. Okay, I think we are more or less done with the first part here. There are some tips here how to do things, but I guess we already said most of them. So save your stuff often, so really do commits regularly so that you can actually see the changes. We are doing quite simple stuff now at the beginning of the course, so it might feel like is this really something, like it feels a bit stupid, and it can be so, but we want you to learn to actually do it regularly so that you will have the habit of doing it. Yeah. I guess this could be a good moment to have a short break, or